Welcome back. In the second half of this lecture, we're going to look at the quadratic formula as another way of solving quadratic equations. So you'll remember from days gone by that if you've written your quadratic equation in standard form, all of the x terms and constant terms on one side, 0 on the other, then you can solve the equation just by using this quadratic formula. So we have a being the coefficient for the x squared term, b being the coefficient for the x term, and c being the constant term. We can find our solutions for this equation, x being negative b plus or minus the square root of b squared minus 4 times a times c, and then the whole thing all over 2 times a. A couple of places just to be careful with your writing. This is usually where people's sloppy handwriting lets them down. Sometimes people will, when they're writing the quadratic formula out, be a little bit careless with the fraction line and have it, for example, sort of stopping a little bit early so it looks like a fraction plus a square root. This 2a needs to be the denominator for both terms. Both terms are the numerator of the fraction, not just the negative b, but also that plus or minus square root. All of that should be on the top of our fraction. The other place where people's handwriting might let them down would be with the square root. Sometimes I'll see people being a little bit careless, and the 4ac is not really inside of the square root anymore, and so when it comes to the calculation side of things, they find the square root of b squared, and then they forget that this also needs to be inside the square root as well. So just be a little bit cautious when using your formula. But one thing also to keep in mind is that depending on what the value is of b squared minus 4ac, that's the discriminant of our equation, if we're looking at solving a quadratic equation, depending on what the discriminant is, we'll either have two different solutions if it's positive, or we'll only have one solution, a repeated solution, if it's 0 for the discriminant. And also, of course, if the discriminant is negative, then that square root won't be a real number, which means we'll have no real solutions. So sometimes it's nice, if you're solving a problem, to maybe first find out what the discriminant is. And if it's negative, then there's no need to go further because, of course, there's no real solutions. So if we're looking at this equation, 3x squared equals 7 minus 2x, first thing, before I think about using the quadratic formula, I'll move everybody so that all of my terms are on one side. So 3x squared plus 2x minus 7 equals to 0. Because before we identify that a is 3, that b is positive 2, and that c is negative 7, we have to have written our equation in standard form. Everybody on one side, constants on the other, 0 on the other side. So now, what do I need to do? Well, first off, we'll calculate our discriminant, and that is b squared minus 4ac, or in this case, that would be 2 squared minus 4 times 3 times negative 7. And if I were to run that through my calculator, 2 squared is 4. Negative 4 times 3 times negative 7, that's positive 84. So my discriminant is 88. So that means that this equation will have two solutions, guaranteed two distinct solutions. And now the only thing left for me to do is to use that discriminant to solve my equation. Because now if I want to solve, I know that x should be equal to negative b plus or minus the square root of my discriminant all over 2 times a. And we know what b and a are, so really we could say that x is negative of b, so negative 2, plus or minus root of 88 all over 2 times a, 2 times 3, which is 6. I want to give one little bit of caution here before I go one step further. And the caution is you may feel tempted at this point to say, oh, I could cancel this 2 and this 6 and turn this into a 1 and this into a 3. Unfortunately, you can't do that. If you're thinking about this kind of canceling, this canceling would be forbidden. Because remember that if you want to cancel something out from the top and the bottom, it needs to be something that's a factor of the entire numerator and a factor of the entire denominator. Now, 2 is a factor of the denominator. 2 does go into 6. But 2, currently, I can't tell whether it goes into both terms. 2 definitely goes into the first term, but there's no 2 or multiple of 2 out front here. So if I plan on canceling, too bad for me, I can't quite cancel yet. You can only cancel if something was a factor of both terms in the numerator. Now, I'm not finished yet, because taking a look at my root that I have there, that root is not in simplest terms. There's a perfect square, namely 4, that goes into 88. 88 is 4 times 22, so really x should be negative 2 plus or minus root of 4 times root of 22, all over 6. Now at this point, we're fine to do some canceling, because now you can see that 2 indeed is a factor in both terms in the numerator. So you could cancel top and bottom, dividing top and bottom by 2, so that we would have 2 solutions. One solution being negative 1 plus the square root of 22, all over 3, and the other solution being negative 1 minus the root of 22, all over 3. All right, we're going to just do some more examples. Ones where we have to do a little bit of decision making as far as how we're going to solve, because now we've got really 3 techniques available to us. We can solve by factoring, we can solve using the quadratic formula, we can solve by completing the square. It'll really be up to you to decide the most efficient way to make that happen. So let's start off with this. I see I've got some rational expressions here, some of which are already in simplest terms. And I have one over here that I don't know if it's in simplest terms or not, because that denominator is not factored yet. So that'll be the first thing that I do. I'll factor my denominator. X squared plus x minus 2 factors as x plus 2x minus 1. Okay. So what I'm going to do as my next strategy here, my next move, is to do the same technique that I did previously, which was in a previous section, in the last one, we had something along the lines of this, where we had a bunch of rational expressions, a bunch of fractions, and I said that if we were to think about what the common denominator would be for those rational expressions and multiply everybody left side and right side by that common denominator, that would clear out all of my fractions for me. So if I'm thinking about my common denominator here, x plus 2, x minus 1, the other fraction has x plus 2 and x minus 1 in its denominator. So x plus 2, x minus 1, that would be the common denominator for all 3 of my fractions. And if I multiplied every term, left side and right side, by that, then in the first term, the x plus 2's would cancel, leaving just the x minus 1 behind. In the next term, the x minus 1's would cancel, leaving just the x plus 2 behind. And on the right side of the equation, the x plus 2 and the x minus 1 would cancel, leaving just that numerator. There we go. And then the only thing left for me to do is realize I made a little bit of a mistake. Oop, let's just fix that. That wasn't supposed to be 3, that was supposed to be 3x. Good thing I stopped before I went too far. That's better. So now we'll just expand things out. 3x times x minus 1. So that's 3x squared minus 3x. 1 times x plus 2, that's just x plus 2. And now once I bring everybody from one side of the equation to the other, so I'll bring the 4 minus 7x to the other side, I'll have 3x squared plus 5x minus 2 equals to 0. And now at this point, you can make your choice as to what to do next. So here I've got my polynomial on one side equal to 0. I could either try to complete the square if I felt like that was a nice choice, or I could just use the quadratic formula, or I could try to factor. Now, factoring tends to be fastest, so that's what I'll start with. And if I can factor, then I'll do it that way, and if not, then I'll need to find some other approach. If I were trying to factor, I'd be looking for numbers that multiply together to give me 3 times negative 2. So multiplying to negative 6, and they need to add up together to give me positive 5. And I'm pretty confident that I can find those two numbers. Two numbers that multiply to negative 6 and add to positive 5 would be positive 6 and negative 1. So now I'll rewrite this as 3x squared plus 6x minus x. And now I'll complete this by factoring by grouping. First two terms, I can factor 3x out, leaving x plus 2 behind. And from the next two terms, if I factored negative 1 out, that would also leave x plus 2 behind. So we'd have x plus 2 times 3x minus 1 equals to 0. So two solutions, we would find that x is equal to negative 2 and x is equal to a third. Let's just give ourselves a little bit of room here. There we go. So we have two solutions in our solution set, negative 2 and positive a third. Now, if you got to this point and you haven't had any warning bells going off in your mind, this is where you should stop and go back to the very beginning and just ask yourself the question, are both of those solutions to the original equation? Remember that what we started with was something that had denominators, something that was a rational expression plus a rational expression equal to some other rational expression. And remember, whenever those denominators are 0, then that would be something that would make those expressions undefined. So good for us to pause and go back and look at the beginning. And one thing you'll notice is that there are two values for x that are excluded. So for excluded values, we know that x cannot be equal to positive 1 because that would make those x minus 1s 0. We also know that x can't be equal to negative 2 because those would make all those x plus 2s equal to 0. And so that means that when we found our two solutions, actually, we found two solutions, but one of them is extraneous. This one, x equals to negative 2, we'll need to reject that solution because it's one of our excluded values. So really, when we're stating our solution set, there aren't two solutions inside of it. There really are just the one solution. X is equal to 1/3. This is one of the things that I mean about needing to be a little bit careful about thinking about the equation, thinking about the values of x that we're allowed to use, because as you can see, it's easy to get caught up in the going step by step and carrying out the procedures, and you might miss the overall importance that for that sort of an equation that we started with, there are values of x that can't be put in, and so we'll need to make sure that the solutions we find are actually solutions. Of course, another way that you might have noticed this would be if you were to go back and check your solutions. If you went back and put negative 2 inside the original equation, you would have one fraction whose denominator was 0 and another fraction whose denominator was 0. And that would be the tip-off that -2 couldn't actually be a solution of the original equation. But if you checked 1/3 for x and put in 1/3 for x in everything on the left side and the right side, 1/3 does make the left side and the right side of your equation equal. So this would be an equation where there's only one solution, and the solution being positive 1/3. All right, a nice little word problem here. I've got an equation that relates S, how high the rock is above the ground, to T, how long it's been since the rock has been thrown. So one little thing that we'll probably want to keep in our minds here is that if time equals 0 is when the rock initially gets thrown, then time itself needs to be something positive. So we need to be thinking about any time we're looking to solve for when does the rock do this or when does it reach this particular height, that we would only really be interested in positive values for time, because that would represent the time after we've thrown the rock. Negative values for t, that would represent time happening before we throw the rock. And of course, before you throw the rock, then this equation wouldn't really make any sense. This equation is explaining what's happening to the rock after it's been thrown. A couple of little bits of strategy here. Since for this problem we're looking to give our answer rounded off to a certain number of decimal places, then that means, number one, there's no real need to spend my time trying to factor, trying to find exact values. I know that I'm only really going to be interested in the approximate value here, so I'll probably think about using the quadratic equation, the quadratic formula to solve. The second thing to keep in mind here, of course, is since this is a word problem, that once I find my solutions, I'll need to write up my answer as a sentence. So first off, the question in part A is, when will the object be 20 meters above the ground? Or in other words, when is S equal to 20? So if we start out with 20 as our value for S, we'll now have that negative 4.9 t squared plus 25t minus 10 is equal to 0. And I'm already planning on using the quadratic formula, so it makes sense here to just take a little bit of a moment and find out what my discriminant is, just to save me a step. I know that my discriminant would be negative b, my discriminant rather would be b squared minus 4ac. Here, my b is 25. A is negative 4.9. And c is negative 10. And when I use my calculator, I'll find, once I've run that through, 25 squared minus 4 times negative 4.9 times negative 10, that's 429. So there are going to be two solutions, two different times at which my rock reaches 20 meters above the ground. If both of those times turn out to be positive values, then both of those will be times that I'll be interested in expressing in my solution. Because again, remember that for this problem, it only really makes sense for time to be 0 or larger. Okay, so now we'll find out what time is. Time is negative b plus or minus my discriminant square rooted over 2 times a. Here, b is 25. And a was negative 4.9, so my denominator is negative 9.8. So now the only thing left for me to do is use my calculator, because again, keep in mind that I'm interested in giving my answer rounded to a certain number of decimal places, so I'm not really going to be trying to simplify that square root. So if you're thinking about is root of 429 in simplest terms? It doesn't really matter because, of course, we're not going to be giving our answer exactly. We'll be giving it as an approximate value. So when I do my calculations, I find that there are two different values for t. So when I calculate with the plus, negative 25 plus root of 429 over negative 9.8, do the same thing with negative 25 minus root of 429 over 9.8. I find two possible values to solve this equation. T is either approximately 0.43752, so that's 0.438. And the other solution, 4.6645 or 4.665. So the rock is 20 meters above the ground. At 0.438 seconds and at 4.665 seconds. And that makes sense with what we would expect. Of course, if you're thinking about throwing a rock, it'll go up for a little while and then gravity will take in and it'll start heading its way back downward. So not a surprise that if we start throwing it from an initial height of 10 meters, that it will reach 20 on the way up, and it'll reach 20 meters high on the way down, and then it'll make its way down to the ground. Of course, that's our next question that we'll want to know is, when does the object hit the ground? When does our rock hit the ground? Or in other words, when is s equal to 0? So again, we're just going to take our equation and try to solve for time. So if 0 is the value of s, then we have this quadratic equation, negative 4.9t squared plus 25t plus 10 equals to 0. And if I find my discriminant, b squared minus 4ac, so 25 squared minus 4 times negative 4.9 times positive 10, that's 821. And so time is negative b plus or minus the root of my discriminant all over 2 times a. So negative 25 plus or minus root of 821 all over negative 9.8. And again, we're looking to report our answer to a certain number of decimal places, so I'm just going to use my calculator to find out now what are the approximate values here for t. And I find that t is either negative 0.37277, so negative 0.373 rather, or the other one being 5.4748, so 5.475. Now, one of these solutions doesn't really make sense. The negative 3.73 would be negative 0.3 seconds before we throw the rock. That doesn't make any sense. Time, we said, needs to be at least 0, since we're starting from time equals to 0 when we throw our rock. So there's really only one solution here, 5.475. So the rock hits the ground at 5.475 seconds. All right, one last example. Does the rock ever reach 50 meters above the ground? So in other words, can s ever be equal to 50? So if we tried to solve this problem, First bringing the 50 to the other side. And now I'll do the same thing that I did before, which is to try to find my discriminant, b squared minus 4ac. So 25 squared minus 4 times negative 4.9 times negative 40. And when I run that through my calculator, I get negative 159. So what that tells me is that this equation has no real solutions. Which means that the rock never reaches 50 meters. And again, we know that because the solutions to that equation would be the times where the rock is 50 meters above the ground. Since there are no real solutions, then the rock never reaches 50 meters above the ground.